Let's do a problem from the book. So let's see where we are. First, 10 minutes and then I'll run over. Yeah, so let's do this first. If you want to roll at some point. By the way, when we talk about where these different values, sine inverse, cosine inverse, and tangent inverse, when we talk about where they get their values, we call these principal values. And you just need to know that terminology, principal values. We've cut the domain down for all of these functions, or all of these relationships, so that they can be functions, and these are your principal values. Let me show you one other thing. I've showed you what they look like. I've showed you what quadrants they function in. A couple other little things we need to know if this is going to work. Let me erase this. You'll recall that if I have a function, f, and I composite it with f inverse of x, what do I get?
X.
I get x. Basically, if I composite a function and its inverse, they just cancel out. So whatever I give as input comes as output. Same thing is true if I write it this way: f inverse of f of x. That's going to give me x. By the way, thank you for not saying 1. About half the time when I ask this question, I say, if you composite a function and its inverse, what do you get? People say 1. No, you don't get 1. It's whatever you put in. If you put in 5, you get out 5. So let's take a look at, we have y equals cosine of x. If I wanted to isolate x for some reason, if I needed to isolate that variable, what would I do? Yeah, I would apply the inverse function so that the functions would cancel out. So what I would do is I would say cosine inverse of y equals cosine inverse of cosine of x. And what happens? These two functions cancel. X is going to be cosine inverse y. So far, so good? Now, this is what's important to remember for some of the problems that you're going to have. Because you'll be asked questions like this. You'll be asked a question, what is sine inverse of cosine of pi over 6? Well, we'll need to step through this, just a piece at a time. What is cosine of pi over 6?
30 degrees.
Okay, so I'll simplify this first.
Root 3 over 2.
So this is sine inverse of cosine of pi over 6 is going to be root 3 over 2. So now I ask, what is sine inverse of square root of 3 over 2? Anytime you have sine inverse, cosine inverse, or tangent inverse, I'm asking for an angle. I am saying what angle of sine gives me the value of square root of 3 over 2. So if I go back to my unit circle over here, I know that square root of 3 over 2 is positive. It's going to be in the first quadrant here. When is my y value in here square root of 3 over 2? And I heard 60 degrees, or pi over 3. If I'm up here at 60 degrees, the value of this point up here is 1/2 the square root of 3 over 2. On the unit circle, the y values are our sine values. So when is sine equal to root 3 over 2? At 60 degrees. So this is just going to be 60 degrees, or if we put that in radians, what will it be?
Pi over 3.
It would be pi over 3 radians. Excellent. What about something like this? Instead of doing sine inverse of cosine, what if I do it the other way? What if I say, what is tangent of cosine inverse of -1/2? Now when I say cosine inverse -1/2, one way of thinking about it is like this. I want to know what cosine inverse of 1/2 is, so I can say, well, cosine inverse of 1/2, I'll say that that equals, we can set it equal to some variable, doesn't matter what. I like to set it equal to theta because I always remember that inverse functions are angles. So I would expect my answer to be some kind of angle. So if I'm having trouble remembering the value, what I can do is I can say, all right, well, I'll apply cosine to both sides. These cancel. So another way of asking the same exact question is saying, when does cosine of theta equal a half? Again, the answer is 60 degrees. If we look up here, our cosine value at 60 degrees is a half. So then this simplifies to 60 degrees. Then the question is, what is tangent of 60 degrees?
Tangent.
What's the definition of tangent?
Oh,
I'm sorry. We did negative a half.
Oh, so
Thank you,
300.
Josh. So we did negative a half. So this wouldn't be 60 degrees. It would be
300.
It would be negative.
300.
And we should think of it. You're right. You're right, sort of. You're saying it's 300 degrees. That's correct if we're going around the circle this way. But you remember we said that we have to limit where cosine inverse is. So you're right. It's the same point on the circle, but we should get used to it. Instead of thinking of it at 300 degrees, we should get used to thinking it as negative 60. Thank you, Jocelyn. It's going to be negative 60 degrees, and so then we ask the question, what is tangent of negative 60? We're down here. What's that value? It's got to be symmetric with this one.
So sine divided by cosine, so
The x value is still positive, but what happens to my y value?
negative.
Thank you. And the definition, at least one definition of tangent, is sine over cosine. So it's this value divided by this value. So I get negative root 3 over 2. That's
So
sine.
it's negative root 3?
That is correct. Over a half. That cancels. It's negative root 3. Yes? I'll put a couple up on the board for you to try. How about this? Let's do sine inverse of tangent inverse of, oops, let's do sine inverse of tangent of, 30 degrees. Let's do tangent inverse of cosine of 45 degrees. That was going to be tough, actually. Let's not do that one. Let's do this one. Let's do that. Let's do tangent inverse of 1 over the square root of 3, and let's take the cosine of that. Now, can you plunk these into your calculator? Yes. However, I don't want you to do that. I want you to use your unit circle to get a feel for doing some of these. So see if you can figure these values out on the unit circle, and we'll go from there.